So this video is another one where I recorded it and then didn't have the audio, so I'm gonna lay the audio on top of it now. So it'll be a little bit weird or off with what I'm writing at times, and I apologize. I'll try to do my best. So we're gonna look at inverse functions here and how to find their derivatives. So first, let's define inverses or recall what our definition is. Basically, you switch the x and the y, or the domain and the range, and that's an inverse. Now I'm writing here that it's the function that results from, but it doesn't necessarily have to be a function. If you take the inverse of x squared, it's not a function. So yeah, but we're going to look at functions in this course. So for instance, if I know f of 5 equals 3, then I know f inverse of 3 equals 5. I switch the x and the y. I like the word mapping here. When you think of f of 5 equals 3, we say 5, the x value 5 maps to 3. Well, the inverse just points back the other way. The 3 maps back to the 5. So here's a graphical representation. On a graph, that would be x squared, and then the inverse is a sideways parabola. It's reflected about the line y equals x. Because you're switching y and x, you're saying that the y equals x, so we can switch them. That's why it reflects around the line y equals x. What we're doing is taking all those points on the parabola, for instance, the point 2, 4, and we're switching the x and the y, and we're graphing point 4, 2 on the inverse graph. So that's why the square root function is the inverse of squared, right? We can erase the bottom part of the parabola so that we can make it a function, and that would be our square root function. All right, so now we're going to look at analytically what it means to be an inverse. Well, if we do the composition of f and its inverse, we get x, meaning algebraically, whatever f does to a function, f inverse undoes it. You can think like addition and subtraction here, multiplication and division, squaring and square rooting. So, and it has to work both ways. If I compose f inverse, or f inverse f, I get back to my input value of x. So what it means is f undoes f inverse, and f inverse undoes f. So again, think of all those operations. So that's how we can show or prove that a function's an inverse. We can do the composition and come back to x. Let's look at when we have a table of values how we do some of this, because a lot of this stuff will be done with tables. So if I look at the table and I want to make a table of values for f inverse, I just take all my y values for f of x, that's 3 and 2, and I point them back to the x values. So 3 points back to -2, and 2 points back to 1. So that's how I make that table. All right, so now we're going to do G inverse. So normally 2 maps to 1 and 1 maps to -2. So now we're going to go backwards and say that 1 maps back to 2 and -2 maps back to 1. So we're just reversing the two things. Right? So we're switching the domain and range, which means the x and the y is on the table. So now we want to find the value of f of g inverse of -2. So we're going to start by finding g inverse of -2. So that means I'm looking for the y value of g, -2. So I look on the y column for g, and then I see what it maps back to. What x does it point back at? It points back to 1. I can also find it on my g inverse table if I've made one. But typically we're not going to make our own g inverse table. We're going to look at that original table there and map -2 back to the x value 1. Now that I know g inverse is equal to 1, I can substitute 1 in for all of this stuff, and now I'm finding f of 1. Okay, so there we go. It's 2. Now I want to find f inverse of f of 1. Well, that notation means they're inverses, so I know that f inverse undoes whatever f does. So the answer is 1. I don't really have to go through this, but I will. But I know the answer is going to be 1 because whatever f does, so 1 maps to 2. Now I can plug that back in for f inverse, and now I'm looking for a y value of 2 to see what x does it map back at or point back to, and it points back to 1. So of course I know it's 1 because f inverse undoes f. So whatever I input in the beginning, which is 1, I get back to 1 in the output, the final output. Now these, I don't know, g inverse and f inverse are different. So first I do f inverse of 2. So I'm looking on the f table to see what 2 points back at, which is 1. I plug that in. Now I have g inverse of 1, and I look down the y value of g to see what 1, the y value 1 points back to. It points back to -2. And the last one, we're going to do a triple composition here. So I start with G inverse of 1. That means I go to the table G. I see what y value 1 points back at. I'm sorry, I find the y value 1. It points back to an x value of -2. I substitute that in, and now I'm finding G of -2, which we pull off the table is 1. And then F inverse of 1. So I'm looking down the y column of F, looking for a y value of 1 and see what x it points back to. There isn't one, right? I don't have a y value of 1. I don't have a range value of 1, so I'm going to say it's undefined. I don't know what it is. Okay, so we want to find a formula now to take the derivative of an inverse. So this formula can be a little confusing to remember, so let's learn how to derive it. If we go back to our definition of an inverse, and we're just going to look at it one way, that if I have f of f inverse of x, I'm going to put f on the outside. That's important here. F of f inverse of x equals x, right? That's the idea that f undoes whatever f inverse did to x in the first place. If I take the derivative of that by chain rule, I do the derivative of the outer and recopy the inner. So that's that part right there, f prime times recopy the inner. Now, times the derivative of the inner. So the inner is the inverse. So I'm going to say the derivative of f inverse. And now that derivative looks a little weird there. There's a lot of notation. So typically I'm going to write it like this. I'm going to say that's the derivative of f inverse. So again, I applied chain rule. I did the derivative of the outer, that's f prime, recopied the inner, that's this part right here, and then times the derivative of the inner. Now the derivative of x on the other side is just 1. Now we want to solve for the derivative of f inverse, which means I can get rid of all this stuff by dividing both sides by that. So that's my f prime f inverse of x. So f prime of f inverse. I divide both sides by that. On the left side it cancels. And so I get f inverse of x, the derivative of that. So the derivative of f inverse is equal to 1 over f prime of f inverse. So I have to do that composition there. And that does not undo it because it's f prime of f inverse. It's not f of f inverse. All right, so that's how we find the derivative of an inverse. And you can memorize that formula, but you'll forget it. I forget it all the time because we don't use it that often. So it's best to remember that a starting point and then be able to do chain rule on that and derive it. That will show up on a checkpoint quiz for sure. Okay, so now we're going to use this to try to find some stuff. So I want to find the derivative of f inverse of 4. So I start by writing out my formula. So I get f inverse, the derivative of f inverse 4 is 1 over f prime of f inverse of 4. So I start with f inverse of 4. So how do I find that? I first have to think of f of x here. I have an equation for it. So I'm going to say that I want to find the x. The y value, -4, points back to what x? So I can put in my -4 for y, solve for x, and then I get -2. Okay, so now I know -2 is equal to f inverse of -4, so I plug that back in, and I get 1 over f prime of -2. So then I do f prime of -2 is 1/3 because they told me that. I could also take the derivative of f, plug it in if I didn't have that information. Now let's do a couple from the table. So find the value of f inverse of 3, the derivative of that. So the derivative of f inverse of of positive 3 is 1 over f prime of f inverse of 3. So I go to my table. I want to find what f inverse of 3 is. So I look down the f column, the y column of f, and I'm looking for a y value of 3. So I'm trying to locate what does the y value of 3 map back to. It maps back to an x value of 1. So let's look at what I have here. So I plug in the 1, and now I'm looking for the derivative of 1. So I go to my table, For an x value of 1, the derivative of that for f is 2, so I get 1/2. Okay, let's do the next one. So that one is going to be 1, and you should pause the video and work that out and see if you can do it on your own. Okay. I don't know what I was doing there. I was freaking out a little bit. All right. So we'll do some more with tables. Find the value of the derivative of g inverse of 1. And then we're going to use that derivative to find the equation of the tangent line to g inverse. I'm freaking out again. Sorry about that. 1x equals 1. So I want the equation of the tangent line. So I need the point of tangency. So I'm going to start with the point of tangency, hopefully. I think that's what I did when I wrote this out. Let's see. Yes. All right. So g inverse of 1, I got to find, I look on the table under the y values for g, and I see 1 maps back to an x value of 3. So the y value on g is 1, and the x value is 3. And that means my point on g inverse will be 1, 3. Because g inverse, we flip the x and the y's. So on my graph of g inverse, I'll have the point 1, 3. Right? I switch the x and the y's of g. Now I want to do the derivative of g inverse of 1 to find the slope of the tangent line at that point of tangency. So I know that's 1 over g prime times, or sorry, g prime of g inverse of 1. So I look on my g table again. I find g inverse of 1 is 3. It points back at the x value 3. So I get 1 over g prime of 3. Now I'm on my table. I look under the x value of 3, and I'm looking for what g prime is, which is negative 2. So there's the slope of my tangent line. It's negative 2. So now I can write the equation of the tangent line to the graph of g inverse. And I think I'll do that. Let's see. There it is. Yep. Alrighty. So this next one is now asking about find the value of f prime of 2, estimate it, and then based on that value, what can you say about the graph when x equals 2? So anytime we have a table, we didn't do well on the checkpoint quiz here, and this is going to show up on other quizzes and stuff. If I give you a table, I always like to ask that question of how do you estimate the derivative, and for an x value that's not on the table. You don't use your derivatives. I'm blocking off that column to show you that we used those f prime values, a lot of us on the quiz. We don't use those, right? We're going to estimate using f. So let's say that I've got a point 1 and 3. I want the point between them, 2 and 3. I want to find what's the slope of the tangent line between 1 and 3, which is at x value of 2. So let me zoom in a little more here. There's an x value of 1. There's an x value of 3. There's my 2. I want to find the slope of that tangent line. Well, what I can do is I can draw the line through both 1 and 3 called the secant line, and I can do the slope of the secant line from 1 to 3. And you can see it's pretty close to being parallel to that tangent line of the point in between. So that's key. I want to use the points 1 and 3 and 3 and 1 and just do slope. So again, I'm using my function values, not my derivatives. And when I do the slope of 1 and 3, I'm finding the slope of that secant line, which is a good estimate for the tangent line. So the derivative at 2, or the slope of the tangent line, is approximately equal to the slope of the secant line. So when I do this out, I've got my y value minus my y value, 3 minus 1 over x minus x, which is negative 2. So I'm getting negative 1 for a slope. That's the slope of the secant line, and that's a pretty good indication of what the slope of the tangent line will be. It's a good estimate. So since the slope of the tangent line is estimated to be negative, then f of x is decreasing at f of 2, or at x equals 2. All right, so a little bit of review stuff there. Now you can try this one on your own and see if you get it right. Pause the video. Okay, so you should get that your estimate was negative 5/2, and then we say since g prime of negative 1 is less than 0, then f of x is decreasing at x equals negative 1. whoops, at x.